Hello everyone, this is Dipak Raut. So I'm creating this video on special request of my student. So this video is about how to write a code in Xinlinx by using Vhdl. So let's start. After installation of Xinlinx software on your desktop, this icon will be created. Xinlinx ISC 9.2i. So this is currently I'm using this version 9.2i. Now double click on this icon. So after double clicking on the icon, this is the window which is given by the Xinlinx ISC. So click OK here. Now here you can see there are four windows. First is the source, second is the process, and here this is the transcript. So basically to check the messages, errors, warnings, this window is here, right? So we'll start here now. So let's say I'm writing the code for 4:1 mux multiplexer here. So how to write the code, how to synthesize it, and how to simulate with the test bench, that we are going to learn in this video. So first, step number one, go to file, new project. So this is new project wizard here. So here project location, first you have to select your project location. So what I'll suggest, you just create your folder with your name or maybe the roll number, and you save it all projects there only. And here project name. So now let's say I'm writing a code for 4:1 mux here. So this is my project name, and always top level source type is the HDL for VHDL and Verilog languages. Then go next. So this is the important wizard here, window here. So here you can see this part is the hardware description. That means, let's say after completion of your code, simulation of your code, you are transferring the bit file on your hardware kit to check the output on hardware kit there. So which is basically FPGA kit. So for that, this is the description of that device. So in our lab we are having the kit with this specification, so that's why we have selected this family Spartan 3E. Under this family we are having this device XC3S250E, and under this device specifically we are having this package PQ208, and this is -4 as it is. So this is basically for hardware description. Next, this part here you can see, or by default HDL is there. Next is synthesis tool XST, and simulator tool ISC simulator. So these are the tools which are used for the synthesize and the simulate the output here, which is basically used for VHDL and Verilog. And preferred language always should be VHDL. Sometimes by default it is having the Verilog, so just change it to VHDL. Then keep all of the settings as it is. Go next, next, next. And now this is the short summary what you have created of your project, with what specifications and with what tools. So if we'll confirm, then go finish. Okay. So now after this will create your project 4:1 mux is the name of my project. At the same time, this will create the device and the package. So XC3S250 is the device, and under this device I'm having -4 speed with PQ208 package. So what description, hardware description we have selected there. Fine. So this is the source window, this is the process window, this is your code window, and this is your transcript where we are seeing all the console messages, errors, warnings here. Fine. Next step, now we have to write the code. So for that you are selecting source. For try to write the code is synthesis and implementation first source. So select this source. Now click on right click on this device, not to the project, right? So whatever works we are doing after this step, that should come under the device only, not under the project. This is important. So right click on device, new source. Now two sources we are using to synthesize the code and to generate the simulated output. So first is the Vhdl module. Here file name, now this is nothing but your entity name. So let's say I'm having my code here, 4:1 mux using data flow, and this is my entity name. So I'm directly taking this name from my code here. Yeah, so you can assign any name here to your entity. So this is what your name of your main entity, which describes your input and output ports, that means external behavior of your design. Fine. So again select the same location which you have created your project, and now add to project should be checked, and then go next. So this is the entity declaration. So whatever input and output ports you are using in your code, so that we have to declare here. But before it, here you can see architecture name. So generally the architecture name I'm assigning as a modeling name. So now in this code, let's say I'm using 4:1 mux using data flow here. So I'm using data flow modeling style. So you can assign the name of data flow. And as we know, it is not case sensitive. VHDL is not case sensitive. So I'm assigning data flow here. Now declare the ports. So for using the data flow, we need to use the input ports as a vector. Here you can see in this code. So that first you have to decide. Right? This is my entity. So I'm just declaring here I is my input. Then select is my again input, and let's say y is my output here. So change this direction out. Now out of this three ports, these two input ports is the multiple bit representation. So that means we have to select the bus here. So bus is basically for what? To represent the multiple bit representation. So now I 4:1 mux means it's a 4 bit. So 0 is your LSB, and 1 2 3 is your MSB. Similarly, select input is 0 and 1, so 1 is your MSB 2 bit. Here Y is single bit output, so no need to use bus. So this is the declaration of entity. Go next. With a short summary, check it once. If it is correct, then go finish. So now this will create first file in your project, that is the .vhd with your entity name. Here you can see my project name is 41 mux this device, and now this .vhd file is created under this device and this file. Okay, so here you can, we'll go with the code now first. So by default, Xinlinx provides by default a library packages declaration. So by default, these three packages is there. So we have discussed this part in theory lecture already. And now you can see data entity is also ready. So two ways to write the entity. Either you can write entity here in this code file .vhd file, or else you can use the first method which we have used here, that is a declaration in entity window wizard. Fine. Now what the part is remaining is what the architecture. So in my code is ready in text, so I'm taking the directly architecture part here. So in between begin and end we have to write the concurrent statement because it's a data flow. Okay, so now next, so we have written the code. Now once your code is complete, just save this file. So Control S. So this is here you can see mux underscore 41 underscore data flow dot vhd file created here. Now we have to check our code whether it is error free or not. So how to check? This is my project. If I'm clicking on project, here you cannot see the synthesize tool. If I'm clicking on project device, again it is not available here in this process window. But if I'm clicking on .vhd file, yes, here you can see synthesize XST tool. So you have to click on .vhd file only. Next, click on .vhd file, synthesize, split this cell. Here you can see check syntax and other options are here. So out of this we are using check syntax and view Rtl schematic. So first check the code. Here it will take some time, and here you can see process check syntax completed successfully. That means my code is correct. And at the same time, let's say if I'm doing like this, if you have to check, I've forgot to write semicolon here. Save this file and you can check here, check syntax. It will give the error, pass error, right? So expecting comma line number 45. So this is my line number 45, but actually error is here, right? So terminated by semicolon, and now again save that file and check syntax. So it will eliminate that error. Okay, and now after this check syntax, if your code is correct, then double click on view Rtl schematic. So this will basically generate the your logic diagram with your external behavior as well as internal operation. I'm double clicking here. So this will create now .ngr file. Yeah. So this is your logic diagram, right? So this is the entity of your design, which is shows the external behavior of your design. And if you try to double click on this diagram, here you can see the internal operation. So I, which is for input line, data input line, this is output, and this is select input here. So in this window, what we learn is how to write the code in Xinlinx using Vhdl, how to synthesize it, check syntax, and how to generate the Rtl schematic here. So I hope step number 1 is clear. So now in second window, we'll discuss about the test bench, how to apply the test bench, how to simulate the output to check the desired result. Thank you very much.